4.2 quadratic relations. So we did a little bit of an investigation in 4.1. So now we're going to look deeper into the properties of parabolas. Okay, so I included a graph right here, and I mean there could be arrows here on this parabola. We have the x and the y-axis, right? So x here and like y is right here. Okay, and I label the axis as symmetry, the vertex, and then the x-intercept and the y-intercept. Okay, just to recap from grade 9, x-intercept is where the graph crosses the x-axis, okay, right here, and the y-intercept is where the graph crosses the y-axis. Okay, so let's start down here, properties of parabolas. So a quadratic relation, this is any relation written in this form. Okay, so this is the expanded, like the fully expanded form. This right here is the simplified form, so without any transformations on it. So y equals x squared, or it could be, we could have like an x squared and an x in that equation and a constant. Okay, so like the a cannot equal 0, or else a would actually just be linear, because then that term would be taken out, and all we'd have left is that x term. Okay, and a, b, and c are just real numbers. And then please note from the investigation that we saw, the second differences are constant. Okay, now a parabola, the shape of a quadratic relation, that is called a parabola. So it's actually like a shape. So if you're like, oh, my favorite shape is square or circle. No, well, now you can consider a parabola shape, okay? And so it's the U shape, it's a symmetrical curve. So we talked about symmetry here, and then you can either call it like the happy face or the sad face. All right, so now vertex. Actually, these three go together. So vertex, optimal value, and direction of opening. That's why I just included one diagram here. So a vertex is the point on the parabola where the curve changes the direction. So going down and then going up, or going up and then going down, okay? So it's going to be that changing point right here or here. So we're going to have a minimum when the parabola opens up, or if it's a happy face, right, the minimum. Or we're going to have a maximum if the parabola opens down, or if it's a sad face. Okay, this is also called the optimal value. So the optimal value is actually the y coordinate of the vertex. So for the vertex, we actually label it h comma k. And that's right here. I wrote it in the diagram. Okay, so the optimal value is just that k value. And the direction of opening, what this means is, does it open up, like is it a happy face, creating a minimum, or does it open down, meaning is it like a sad face, the arms are facing down, and that creates a maximum. So which one is it? And parabolas can just open, like the base parabola of a parabola opens up, but then if we reflect it and we flip it down, then of course it opens down. Okay, now axis of symmetry. Axis of symmetry is the line that divides a parabola into two equal parts. So we kind of already saw this. Okay, so going back to the vertex is h comma k. The axis of symmetry is actually going to be that h value. So we saw the optimal value is going to be the k value. The axis of symmetry is going to be the h value. Okay, and it's going to be in the form x equals h because it's an entire line. We want to quote it as the vertical line. And then just please note that the parabola is symmetric about this line. I'm going to scroll down. Now, x-intercepts are zeros. So this is where the parabola crosses the x-axis. So there could be two x-intercepts, like in this first parabola. Okay, this being the x-axis. There could be one x-intercept, that's like right when the vertex hits the x-axis, or there could be zero x-intercepts. So it could just be like in the air, or maybe like opening down, but from down here, right? So always think of like the reverse, or like the flip as well. Now let's get into a couple questions. Let's go ahead and graph x squared for -3 to 3. So we've already seen this, and we should be familiar. -3 squared negative 2 squared, negative 1 squared, 0 squared, 1 squared, 2 squared, 3 squared. Okay, this is the base parabola, and you're going to be able to recognize that and rhyme it off very quickly. Okay, so negative 2, 4, 3, 9. And I graphed that quite quickly because we should be used to graphing from at least grade 9, maybe even grade 8 or grade 7. Okay, we're going to label this y equals x squared. What we're actually focusing on in this lesson is like the following. So first of all, where's the vertex? Okay, so the vertex is where the graph either makes a minimum or a maximum. So this right here is the vertex, and it's going to be at 0, 0. We can also see in this chart, everything's symmetric about the vertex. Okay, so if we increase our x values by 1 or decrease it by 1, our y value is symmetric. It's going to be the same. If we decrease our x values or increase them by 2, again, our y value is the same. Okay, direction of opening. This is a happy face here. It's opening up, okay, because the arms are extending up. See these arrows? Okay. What's the equation of the axis of symmetry? So we can look at the graph and we can identify it right here as 0, or we know that it's going to be x equals then whatever this h value is, so 0. And then the min or the max of y, this is going to be the k value, and this is going to be y equals, let's go 0. Let's not even put y equals. Let's just put 0. And then this is going to be the split of the vertex 0, 0, h, k. Okay, so now what we're going to do is we're going to graph y equals negative x squared. Okay, so this is going to be negative 9, negative 4, negative 1, 0, negative 1, negative 4, negative 9. And if you need to see how to do that, it's y equals negative, and then let's say negative 3 squared. Okay, when we're using BEDMAS, we want to do this negative 3 squared first. So it's actually negative of the number 9, so it's just negative 9, and that's how we get it. So if we were to graph this, and this one should have been easy as well, we should be able to recognize that this is just our parabola reflected in the x-axis. Okay, this is going to be y equals negative x squared. So now, where's the vertex? Well, the vertex is here, 0, 0. We can also identify the vertex as the middle number here. And it doesn't actually have to be the middle number, but it has to be so that the numbers beside it are symmetric. That's the only way that you're going to be able to recognize it. Sometimes the vertex will not actually even be in this table of values, so just be careful. Okay, direction of opening, we say down. So if you look at where the arrows are pointing down. Equation of the axis of symmetry, well, that's going to be the x value of the vertex. Or we can look at the graph. It goes through x equals 0. And the min or the max of y, so it's a max this time, and it's again 0. And they're not always going to be this pretty, but I just wanted to give you the base ones. Now let's take a look at a graphing calculator example just for fun. Okay, an arc in the BCE Place Galleria can be approximated by this relation right here. So let's go ahead and put that in a graphing calculator. Okay, where y is the height in meters, so that's going to be the y-axis, and x, above the floor, and x is the width in meters from the center of the hallway. So I'm assuming that our arc's going to look like it's at the highest point at the center. So let's go ahead and graph it on the calculator, and then we're going to sketch it. So I'm just at Desmos.com, and I'm going to put y equals negative 0.55x squared, and I think it was plus 26. Okay, so what do we want to plot? Well, I want to plot the vertex, which I get is 0, 26. Okay, So 0, 26 is going to be up here somewhere, right? And then I want to plot the x-intercepts. So I get negative 6.8. Let's just round to one decimal. Negative 6.8 and then 6.8. Okay, so we're going to go negative 6.8, which is going to be here somewhere, and then 6.8. So label the coordinates of the maximum value and the x-intercepts. So negative 6.8, comma 0. And then we have 6.8, comma 0. And then we have 0, comma 26. Okay, now let's actually draw the graph. Now I want to point out that because this here, the x-axis represents, when y equals 0, what that represents is like the height in meters above the floor. So y equals 0 represents the floor. So this arc is not going to go into the floor. It might in theory go into the ground a little bit just for stability, but it's not actually going to go into the ground with arrows on it. So we're actually going to stop just like this, okay? So determine the height of the arcs or the arches, okay? 26 meters. Now determine the width. Well, we have 6.8 to the left and 6.8 to the right. So let's go 6.8 times 2, 8, 8, 16, 6, 6, 12, 13, 13.6 meters. And there's an application.